All right, the reason for doing this quiz is to give my students feedback. Are you getting the big ideas down about experiment design? Question 1 involved this quote, and the question is, what does this have to do with experiment design? Why is this super relevant? And what this student is saying, or former student, is that I started off with traditional thinking and eventually I switched over to the scientific method and I was much better off. This is a real important point, and let me illustrate some of the differences. So I built this table. So some examples. Many years ago, nearly everyone believed that the Earth was flat and the planets revolved around the Earth, and only a few rebels believed the Earth was round and the planets revolved around the Sun. And these people were burned at the stake, imprisoned, etc., for believing in data. In traditional thinking, when people get a new idea, they tend to be open-minded as long as the idea agrees with what they already think. But if the idea is contrary to what they think, they are very often closed-minded. That idea must be wrong because it doesn't agree with what I think. When people adopt the scientific method, they're open to ideas, especially ideas that are very contrary to the way they think. It's 180 degrees opposite. All right, the basis for reality in traditional thinking is agreement with me or what the crowd believes, tradition, groupthink. And the basis for reality in scientific thinking is data, i.e. observations about the world, evidence, reasoning, the research, literature, the collective wisdom of humankind. Skepticism. In traditional thinking, people are very skeptical about ideas that don't agree with what I already think. In the scientific method, I'm very skeptical about my own ideas. I'm very skeptical about tradition. Traditional thinking is natural. It's hardwired into the human brain. Our brain always believes that we are right and we have the best ideas. One of the experts in critical thinking in the country is a personal friend of mine. He estimated that about 90% of the population is stuck in traditional thinking. The scientific method, on the other hand, is not natural. It was invented by people and it's quite rare. It's learned, and it really comes from recognize and accept emotions and don't let that block good, clear thinking. Traditional thinking tends to be dualistic. Things are right or they are wrong. Kind of like second grade, like 2 + 2 is 4. And things are either good or bad. In the scientific method, it's a continuum kind of thinking. Poor, good, better, excellent, no upper limit. Right and wrong really don't exist, except for factual things like 2 + 2. In traditional thinking, there tends to be an anger and rejection of people who do not see the world as I do. There's angry arguments, name-calling. We see tribalism. People in traditional thinking will kill outsiders. In scientific thinking, it's about learning from all people, especially those with a different worldview. It's about dialogue and trying to find the best ideas. Accepting all people, it's about collaboration. In terms of learning, traditional thinking is about keep doing the things the same way, even when they're not working. The scientific method, also called critical thinking, is continually innovating, changing, learning every day. My beliefs are constantly shifting. So what Josh is saying, I'm much better off if I'm open to ideas, especially ideas that are different than me. I'm much better off if I base my decisions on data and evidence and reasoning and the research literature. I'm better off if I'm skeptical about my own ideas and about tradition. I'm constantly challenging and growing. And it's much better to think in terms of a continuum instead of right and wrong, instead of black and white. I'm much better off if I learn from all people, especially those that are different than me. And I really like to collaborate with people who are different than me. And I'm really much better off if I'm continually changing, growing, and innovating every day. And this is what the scientific method or critical thinking is all about. And this is essential for doing experimental work. Okay, this next question is about validation. What does it mean? What's in it for me? How does it benefit me personally? And how would an engineer best answer these questions? So I put together some ideas here to help you understand validation. So it's about relentlessly double and triple checking anything that can go wrong. There's so many things that can go wrong in an experiment. And you just get on top and catch a lot of the things. And it's relentlessly questioning and checking what I believe to be true and right. Is this knowledge correct? I'm thinking about this like this. Is this like this? It's just this constant skepticism on what I am doing. What's in it for me? Insanely high levels of learning and growth. It's really fun to figure out how to do this. It creates this incredible humbleness because you really start realizing how hard it is to really know something accurately. This real openness to other people. And it's personally very satisfying because when you put your work out there in the public, you go, I've done my absolute best to check this and make sure that it's okay, free it from bias, etc. The next question dealt with quality. What does quality mean in any circumstance? What does quality in experimental design mean? And then what's in it for me if I focus on quality? So to review the lecture, it's the degree of excellence in a performance or product. It's what makes people really energized and positive. It's what people will pay money for. When I think about quality and performance, I think about Bruce Springsteen. His concerts are amazing and a lot of people will pay money for them. Quality and performance in basketball, of course, I think of Michael Jordan. Quality and performance in technology, I think of Woz. This person by himself designed the personal computer, and I think of Jobs. This person started one of the best companies and the biggest companies ever, and he did it when he was very young. When I think of quality in products, I think of really good best-selling books. This is one of my favorites, The Hunger Games. I think of a Toyota Tacoma, which I happen to drive and really love. I think of the iPhone, quality in another technology product. So what's in it for me to focus on quality in my experimental work? Well, it's super challenging. And we engineers, we like challenge. People will pay you money if you can do high quality experimental work. And you get to do hands-on work nearly all the time. And if you're like me, I love doing hands-on work. It's one of the best possible ways to learn because you're constantly checking and double checking and trying to figure out what's going on. And there's just tremendous learning. Consequently, experimental work to me is super motivating, and I've done hundreds, if not thousands, of experiments. The next question dealt with the weighing project. And what are the best ways to build quality into this project? And what we're looking for is real specific examples. So here's how I kind of start thinking. If I could design an instrument that people all over the world could use, that would be cool. My work would get applied. I bet someone else has used a force-sensitive resistor with an Arduino. I'm going to do some lit review and find out. An FSR has some problems for use in a scientific instrument. So I'm going to calibrate that with a calibration mass like a 50 gram weight and make sure that it's reporting accurate data. But you kind of get the idea. What's really important here is to come up with very specific things that apply to the weighing project and find things you can do that are fun for you that will drive quality up. Okay, I scored each problem as 3 points. And I'm kind of looking at critical thinking here, and this is really pretty hard to do, but I just read it and try and make some judgment about how well you're getting the ideas down. And I do the best I can within my time constraints, but again, it's kind of challenging. But it is a little bit messy. And if you're at about 9 to 12 points, this is about where you should be. You're doing good work for your level in school. If you're doing 6 to 9 points, you're on track. You might want to keep doing the same things, look at the feedback, maybe try and get it a little bit better. If you're getting less than 6 points, you might want to rethink how you're doing things. You're not picking up some of the big ideas, and so that suggests there might be a better way to go about learning. That concludes this video. We'll see you next time.